All right, so in this video, I will be talking through the study assignment for Unit 3. This way, if you are trying to work on your studying for your test tonight and there's any problems that you are stuck on, you have this as a resource to look at. So please make good use of it. I'll start with these ones here. I'm just trying to match the graph to the story that it goes along with. So I'll read the story and then determine which graph it is. So Eric went for a walk at night. After a while, he turned around and started to walk home. Before he got home, he froze after hearing a strange noise. I'm going to connect that one here because he's walking, turning around, walking, freezing. And his distance stops changing. All right, while Tim was driving to school, he decided to stop at Dunkin' Donuts. After getting his coffee, continued on to work. I'm going to go with that one because he's going to work, stopping to get coffee, continuing on to work. To school, sorry. School is work for me, not for you guys. And then for this one, we have Manny went for a run. After a while, he got tired and decided to walk home at a much slower pace. There's that one, right? He's going quickly away from home and slower back. All right, now we're identifying just the types of slope here. So if the line goes up, then it is a positive slope. If it's straight up and down, that is an undefined slope. Remember when our slope tells us what is the change in y associated with a change in x. And so here we have undefined because we're not changing x, right? For all of these values, x equals -5. So it doesn't make sense to talk about the change in y associated with a change in x because we're not changing x. So it's undefined. It doesn't make sense. This one is negative because we're going down as you go from left to right. And this one is 0, right? Because here we can change x all we want and y doesn't change. So the change in y associated with a change in x is 0. Okay, so we're just identifying the x and y intercepts of this graph. So for example, the x-intercept here is located at 2, 0, and the y-intercept is located at 0, 4. The slope of the graph is the change in y over the change in x. So what is my change in y? Well, it is -4. I'm going down 4. And what is my change in x? Well, my change in x is 2. I'm going over 2. So -4 over 2, that's going to be -2. Remember to make sure it's negative, right? Because this line goes down, we know the slope has to be negative. And then to find the equation, well, it's going to be y equals -2x because our slope is -2, and we know our y-intercept is 4, so we put +4 there. All right, now this one is in standard form and we want to find its graphs. This is where we want to find its intercepts by setting x equal to 0 to find the y-intercept, setting y equal to 0 to find the x-intercept. So -2 times 0 plus 5y is equal to 10. That means 5y is equal to 10 because -2 times 0 is 0. We divide both sides by 5 and we get y is equal to 2. Meaning our y-intercept is 0, 2. All right, and now when we set y to be 0, we get -2x plus 5 times 0 is equal to 10. -2x is equal to 10, meaning x is equal to -5, meaning our x-intercept is -5, 0. We can go there, we can draw the line through them. All right, and then we want to write this in slope-intercept form. So you can either do that by kind of adding the 2x and then dividing everything by 5. That works. Or you can also do it visually, which is what I'm going to do. So I can see visually that the slope is going to be 2 over 5 because when we go from this point to this point, we go over 5 and we go up 2. And then the y-intercept would need to be 2. Because that's what we found above. So it's going to be y is equal to 2/5 x plus 2. All right, so we want to graph the line through the points 3, -2, so that's there, and -2, 1, so that's there. And then we're going to graph the line between them, so just connecting the dots. The slope of this line is going to be -3/5 because we see that we're going down 3 when we go over 5. So our rise over run is -3/5. And we want to rewrite this in point slope form. So we're using our point here. I'm going to use this one as my x1, y1 for this line down here. So I'm going to say y minus 1, because my y1 is 1, is equal to -3/5 times x minus -2, which is the same as saying this is equal to x plus 2, because we're subtracting a negative. If you use the other point, another totally acceptable answer is this one right here. Right, that is, oh, sorry. Nope, I got that one wrong. This one would be a wrong answer. This would be a right answer. Y plus 2 is equal to -3/5 x minus 3, right? That is totally okay. We're just doing the same method, right? Still using our x1 and y1 like we did there. Just now we're using the other point, so it becomes kind of x1 and y1. All right. Question 6, we're just finding the slope between these two. It's going to be our change in y over our change in x, so our change in y is -3 minus 1 over our change in x, which is 6 minus 2. It's going to be -4/4 or -1. Graph the line from slope-intercept form. So we're going to start with our y-intercept at -1. And then if it's -3/2, we want to go down 3 when we go over 2. Just remember rise over run, and then remember if it is positive, the line's going to go up, but in this case it is negative, so the line's going to go down. So we want something that looks like this. And then here we're graphing from point slope form. So here we want to decode this a little bit. So we think about this as y minus y1 is equal to m times x minus x1, right? That's our general point slope form. Well, then we can see that our slope is -1/2. And our point, x1, y1, well, we can see y1 is going to be 3. And our x1 needs to be -1. So that it becomes x plus 1 in the final equation. And so when we go to graph it, it's going to be a line through -1, 3, with a slope of -1/2. So we can go over 1 and down 2. And it's going to look something like this. All right. And then which slope is one that is parallel to this line over here? Remember, if two lines are parallel, then they need to have the exact same slope. So the slope of this line, we know it's point slope form, so we know the slope is -3, meaning the parallel line will also have slope -3. If it's perpendicular, then we know it's the negative reciprocal. So if we know the slope of this line is 5/6, the slope of the line perpendicular to it has to be -6/5, and that is answer C. All right, so then for 10 and 11, we are finding all of the lines that are parallel. So how we would read that is we see this one, and we see that m is equal to 2. So it means we want to find all of the lines in this set where the slope is equal to 2. We might need to do some work to uncover that slope. So I'm going to start by adding 2x on both sides here. And this one is going to become y is equal to 2x plus 4, which does indeed have a slope of 2. So this is one of our solutions. Here, I'm going to need to divide both sides by -2, and this becomes y is equal to -1/2 x, right? Negative x divided by 2, or sorry, x divided by -2, which is the same as multiplying by -1/2. That's not going to have the same slope. Same with this one. When we subtract 5, we get y is equal to negative 1/2 x minus 5. That doesn't have a slope of 2, so we don't include that. This doesn't have a slope of 2, so we don't include that. This one will have a slope of 2 because that's in point slope form, so E is part of our solution there. The first thing I'm going to notice here is that we're dealing with the same set of potential answers, but now we're trying to find perpendicular to. So if this slope, if the original line has a slope of 2, then the perpendicular lines, right, it's going to be perpendicular if it has a slope of negative 1/2. So you want to look through all of these and figure out which ones are going to have a slope of negative 1/2. And I can kind of piggyback on the work I did on the last problem. I can see that both B and C are going to have slope of negative 1/2. And so those are my answers there. Notice how this one is not an answer because even though it is the reciprocal, it's not negative, right? It's positive 1/2. So these two lines are not going to be perpendicular. So these are our only answers. Okay? We want the equation of a line through the point 4, -3, parallel to this line. So if it's parallel, then it's going to have the same slope. So we know we're going to be looking for -3/5 plus b, 3/5x plus b, that is. And we want to use our point to solve for b. So it's going to become -3 is equal to -3/5 times 4 plus b. It means -3 is equal to -12/5 plus b. And we want to add 12/5 to both sides. And so now we have -3 plus 12/5 is equal to b. That means -15/5, right? Creating a common denominator here. Plus 12/5 is equal to b, meaning b is -3/5. So putting that all together, our final answer here would be y is equal to -3/5x minus 3/5. Okay? And so now if this one's going to be perpendicular to this line, well, then its slope needs to be the negative reciprocal. So this is going to follow the form 5/3x plus b. And we want to use this point to try and find the value of b. That means 6 is going to equal 5/3 times -5 plus b. 6 is then equal to -25/3 plus b. Add 25/3, add 25/3. We see that b is equal to 6 plus 25/3. B, that's gonna, or 6 is 18/3 plus 25/3. Meaning that the final answer we're gonna get for B is 43/3. And so our final answer here is y is equal to 5/3x plus 43/3. Right, the numbers here, we don't need clean numbers. We know how to work with fractions, so that is a totally acceptable answer. All right, so then for 14, we want to find the distance from these 2 points. So we're going to use our distance formula. D is equal to the square root x2 minus x1 squared plus y2 minus y1 squared. That's going to be the square root of 6 minus -3 squared plus let me do that in the right order. Going to be -5 minus 4 squared plus 6 minus -3 squared. So that's going to be D is equal to the square root of -9 squared plus 9 squared. That means D is going to be equal to the square root of 81 plus 81. Remember here the negative is squared as well, so this needs to become positive, meaning D is equal to the square root of 162, which means it's about equal to 12.7. And then for the midpoint here, we're going to use our formula x1 plus x2 over 2, comma, y1 plus y2 over 2. So for the x's, we're going to get 4 plus negative 5 over 2. That's going to be negative 1 over 2. And for the y, we're going to get 6 plus negative 3 over 2, which is going to be 3 over 2. So the midpoint here is going to be at negative 1 over 2, comma, 3 over 2. Okay, so then we have this line segment. We want to find the coordinates of the endpoints. So the left endpoint is going to be at negative 5, 1. The right endpoint is at 4, 0. Finding the distance between them, that is the square root of 4 minus negative 5 squared plus 0 minus 1 squared. It's going to be the square root of the square root of 9 squared plus negative 1 squared, which is the square root of 81 plus 1, the square root of 82, which is 9.05, I believe. Somewhere in that ballpark, as long as you have the square root of 82, then you're good. And then to find the midpoint, going to be negative 5 plus 4 over 2, comma, 0 plus 1 over 2. That's going to turn into 1 over 2, comma, negative 1 over 2, comma, 1 over 2. And if we graph that, that makes sense because that's going to be right here, right? Negative 1/2, 1/2, which does indeed look like it is the midpoint.